Okay, so today our topic is SONiC web app, SWA, programming SONiC apps in the web browsers. And we are the Dreamcatcher team, and we are a joint team of Microsoft Research Asia Networking Research Group and Microsoft Azure Networking. Okay, so nowadays we know that SONiC apps are built by Docker. So we have a lot of existing apps like the LLDP, BGP, DHCP, or database, or even the utility. Okay, so our question is that can we develop SONiC apps in web browsers? Because we know there is a trend that currently web app-based apps are more and more popular. We know 10 years ago, we use in our computer, we use a lot of native apps like Excel, Word, PowerShell, and Photoshop. Yeah, but nowadays we see more of the web-based applications like Teams, VS Code, Facebook, and Slack, Figma. Okay, so this is the architecture of our SONiC web app, also called SWA. So we can see in the SONiC, we add a new module called the SWA Bridge. And on top of it, we have a Chrome browser here. And it will host multiple web applications. And we can even download a new web application from the App Store. And for the bridge module, we can talk to the SONiC by the Redis database and by the FAIR interface and also network ports. And even for the SONiC developer here, he can see this in another machine. The SONiC developer just need a Chrome browser, and he can locally develop a SONiC web application. And it will talk to the SWA bridge module by the SWA bridge protocol. So SWA are suitable for many scenarios like the network management, like SMP, SDN, and also testing new features like P4, DDoS, and also do network troubleshooting and telemetry. So what can the SWA do? So first, we can build new applications using the JavaScript language or all the WASM supported languages like C++, Python. And we can also port existing applications to SWA, like the BGP, the CLI. So in our prototype, we have ported the SONiC CLI, also called SONiC utilities, to the SWA. So why we do this is because before our job, the SONiC CLI code is heavily bundled with the SONiC OS, right? So if we want to do a code change, we need to rebuild the OS. Yeah, but after our work, the CLI can be decoupled with the SONiC OS, and it can be developed in a standalone way. So we can even develop the CLI code in the Windows OS. Okay, here is some background about our technology. The WASP is also called WebAssembly, and it's a binary standard supported by all the browsers. Okay, and also we can easily compile C++ code to WASP to the browsers where the Mscripton SDK is an open source project. So we can see the C++ code has been compiled to the WASP module and JS code, and then run in the browser. Yeah, and we can see here, it just runs a hello world here. We can see this is a web page. And also it's very easy to run the Python code in WASP via the PyDad open source project. Okay, so here is the SONiC CLI project. Yeah, it's the CLI of the SONiC OS, and the GitHub repo is SONiC utilities, and most of the code is written in Python. Yeah, and it depends on a lot of dependencies like the Durbin packages and the Vue packages here. So it's a very complex project. And this is the architecture of our CLI app based on the WASP. So we can see first we have the patched CLI code, and then we have provided the SWA Python SDK, and then here is the WASP and PyDad runtime, and then we also provide the SWA JS SDK and the HTML code. And it's all run in the browser, and it then talks to our SWA bridge via the HTTP or WebSocket protocol. And for our bridge, we will talk to the network ports, the Redis DB, the file system, all the CLab and system calls. So this is our Python SDK. So it provided at least two modules, Redis SDK and a file system SDK. and also other SDKs. And for our JavaScript SDK, we have provided the fetch API and WebSocket API wrapper, dependency loader, and the command runner. Also for the HTML part, we have provided the terminal UI developed by the Xterm.js. Okay, so finally we have built a prototype, and it's developed locally in another OS like Windows, and it's not a remote shell or remote development. And most of the CLI commands have been supported. So here I will show a live demo. So you can see this is my Chrome browser, and then I can load the dependencies. And here I can run the command like show IP, and throw IP route. Okay, so we can see the command has been successfully executed. And I can also run show net. Okay, and let's see code modification. First, we can see the page source. Okay, so you can see this is loading the dependencies like the view packages. Okay, and this is the terminal UI part. Okay, and this is the code render. Okay, so we can see this part. Yes, this part and response is actually the running the Python code. So it's the entrance of the CLI code. Okay, so here let's see the code modification. Let's copy this information here. And this is the source code, and we can see I'm in a Windows machine. So I can search this code and add some words like a new message here. Okay, and then I can refresh the page. And then show net again. Okay, so you can see now the command has been changed. I have added my message here. Okay. So because of time limit, I will not change more complex commands. Yeah, but it's possible. Okay, so for next steps, we consider to release this SDK in future when ready, and we are also porting more existing apps like FR routing software to build the routing servers. Okay, thank you.
Okay, thanks, Yang from China. Yeah.
Okay.
Any questions? Yeah. Yeah.
Yeah. What is the footprint of all of this? I mean, if you would have FRR running externally through the web browser at Bridge, the performance, is it acceptable, at least theoretically?
Yeah, actually, we have initially measured the performance, and the performance is acceptable because even we run the web applications in another machine, it will be in the same intranet, and the latency will be less than 100 milliseconds. Yeah, so I think it's acceptable for the control message transmission.
Okay, thanks.